Hi everyone, I am Dr. VSB Chaitanya Duvari, working as Assistant Professor in the Department of Electrical and Electronics Engineering, BV Raju Institute of Technology, Narsapur. Today we are going to have some introduction to our course, Microgrid. The intended audience for this course are final year BTech graduate students of Electrical and Electronics Engineering. And the basic prerequisites for this course is basic knowledge of power electronics and power systems. The content for this course is taken from these three standard reference books. So what are the content was made for this course is taken from these three standard reference books. Microgrid Architectures and Control, it is an Ville publisher book, and Microgrid Design and Implementation, so this is a Springer publisher book. And this is Power Electronic Converters for Microgrid. Let's coming to the content for Unit 1, Introduction to Microgrid. So we'll start with the introduction to the microgrid definition, and then we'll go for the typical structure and configuration of a microgrid and what is the significance of microgrid. Then we'll go for the types of microgrids, which includes AC, DC and hybrid microgrids. So this is a typical structure of a microgrid, where you have some electrical distribution system, and then you have some kind of loads, and as well as the renewable energy sources. These loads and renewable energy sources will operate and controlled in a coordinated way, maybe connected to the main grid or maybe operating in an islanding mode as an autonomous or islanded system. So when it comes for the types of microgrids, so we are going to discuss about what exactly AC microgrid stands for, and then we'll go for DC microgrid, and then we'll go for something called hybrid microgrid, which combines the advantages of going for both AC and DC microgrids. In the Unit 2, so we'll be concentrating about what are the microgrid control issues. So in that, we'll start with the introduction to the control function. So where we'll discuss about the upstream network interface functions, then we'll go for the microgrid control, then we'll go for the local control and protection. And what is the role of ICT, information and communication technology, in microgrid, and then we'll go for some microgrid control architectures, and then we'll discuss mainly about what is called as centralized and decentralized control. In a centralized control, the decision making authority and the control is concentrated at a single location or a single entity, whereas in case of a decentralized control, the decision making authority is distributed among multiple entities, multiple independent entities. So this is some difference between these centralized and decentralized control, but we'll go in depth when the course starts. And in Unit 3, we'll discuss about the power electronic converters for microgrid. So where we'll start with what are the different modes of operation for microgrid converters. So we'll discuss about the different modes like grid connected mode, and then we'll discuss about what is a standalone mode or islanded mode of operation. And very importantly, we'll discuss about something called as battery charging mode. And mainly we'll discuss about what are the different converter topologies that are used in microgrid. So we'll start our discussion with something called a two-level grid connected inverter with LCL filter and multi-level voltage source inverter, NPC, neutral point clamped and cascaded. And then we'll discuss about the three-phase current source converter as well as something called as a matrix converter. And what are the various modulation strategies, and what are the control and system issues and future challenges and solutions. And in Unit 4, since in a microgrid, DGs are integrated into the distribution system, so it imposes some challenges to the traditional protection system. So we need to discuss about what are the key challenges, key protection challenges in a microgrid, and then what could be the solutions for these key protection challenges. And then we'll take some case study, and in that case study we are going to study about how the fault current contribution is going to have fault current modification means without DGs and with DGs. In this case study, we'll take this case study as an example, and we'll try to analyze without DG and with DG, what is the fault current modification level is going to change. And in unit 5, we'll discuss about the benefits of microgrid operations. So where we'll discuss about various benefits like economic benefits. We'll concentrate on the technical benefits as well as environmental benefits as well. So then we'll go with something called setup of benefit quantification study and quantification of microgrid benefits under standard test conditions. So these are the list of contents which we are going to go study in case of a benefits of microgrid operation. So the content for this course was taken from the 3 standard reference books which I have shown you in the second slide of my presentation. So all class lectures, e-content is provided in the form of PPT presentation, and all the content of the course will be available in the form of short videos for better understanding and accessibility to the students, as well as during the course, microgrid course, we'll try to simulate some, we'll do some kind of simulations for microgrid systems using MATLAB, Simulink, as well as discussing some research papers during the course of time for better engagement of the students. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.